In this section, we're going to talk about the power function. The power function is the function with the general form of f of x equals to x to the power of n, where n is a constant, x is the independent variable like always, and we call x the independent variable because x is our input, and what our input is defines our output. Now let's see the case where n is greater than 0. So n equals to 1, 2, 3, 4, and so on. This will yield for us power functions of the form f of x equals to, for the case where n equals to 1, x to the power of 1. Or we could also have x to the power of 2, x to the power of 3, and so on. And we recognize these types of functions, and we've talked about them before. They are called polynomials. Now we remember that polynomials are functions with the general form of a sub n times x to the power of n plus a sub n minus 1 times x to the power of n minus 1 plus, and this goes on till we reach the last three terms of the polynomial, which are a2 times x to the power of 2 plus a1 times x to the power of 1 plus a0. N is called the degree of the polynomial, and these a's are constants or the coefficients of the polynomial, and x is an independent variable. For the case where n is equal to 2, we get this polynomial. Px equals to a2 times x to the power of 2 plus a1 times x to the power of 1 plus a0. And now we can see the similarity between a polynomial function and a power function. These terms are just power functions added with one another. So for the case where n is greater than 0, we get these power functions, and whenever n is equal to 0, we get f of x equals to x to the power of 0, which is 1. So to reiterate, whenever n is equal to 0 or bigger than 0, we get polynomial functions, and they are just power functions. Now let's see the case where n is equal to a fraction. So 1 over a constant, let's call it a, and this would give us functions, power functions of the form f of x equals to x to the power of 1, or we can get x to the power of 1 over 2, or x to the power of 1 over 3, and so on, so forth. Now these are what we call root functions. So for the case where n is equal to 0 or bigger than 0, like 1, 2, 3, and 4, we get polynomial functions. And for the case where n is fraction, where we get power functions of the form x to the power of 1, or x to the power of a half, or x to the power of a third, we call these functions root functions. And the most popular type of root functions is the square root function, this function, and we know that we can write this function as the square root of x, and this is equal to x to the power of a half. Another popular root function is x to the power of 1. It's the linear function, and dare I say it is the most popular function in all of math. The linear function is a root function. It's a subcategory of the power function. It's a polynomial function also, because for the case where n is equal to 0 or bigger than 0, like 1, 2, 3, and 4, we get polynomial functions. And for the case where n is equal to 1, we get x to the power of 1, and that is a polynomial function. And for the case where n is equal to a fraction, we get root functions, and one of those root functions is x to the power of 1, which is again a linear function. Now let us examine the case where n is less than 0. So -1, -2, -3, and so on, so forth. We will get power functions of the type of x to the power of -1, and x to the power of -2, and x to the power of negative 3, and so on, so forth. These are what we call reciprocal functions, and the most popular function amongst the reciprocal functions is the function f of x equals to x to the power of negative 1. We know that we can write this function as 1 over x. To reiterate everything, power functions are functions with the general form of f of x equals to x to the power of n, where n is a constant. If n is equal to 0, we get f of x equals to x to the power of 0, which is 1. If n is equal to 1, 2, 3, and 4, and so on and so forth, where n is bigger than 0, we get x to the power of 1, x to the power of 2, x to the power of 3, which are basically polynomial functions. And for the case where n is less than 0, we get reciprocal functions, and the most popular reciprocal function is x to the power of negative 1, which is equal to 1 over x. For the case where n is a fraction, like 1 over a, where a is a constant, again, we get functions of the type x to the power of 1, x to the power of a half, x to the power of a third. We call them root functions. And wherever we talk about a new type of function, in this case power functions, have to talk about their domain and their range. And basically, depending on what n is, the domain and range of the power function will differ. So, for the case where n is equal to 0, we get f of x equals to x to the power of 0, which is 1, and we know that there are no restrictions on the input, and we can input anything and everything. What we get in the output will always be 1. And so its domain is equal to r, so all of the natural numbers, and its range is equal to 1. We will always get 1 no matter what the input is. For the case where n is equal to 1, 2, 3, 4, and so on and so forth, we get power functions of the type x to the power of 1, x to the power of 2, and so on, so forth. These are just polynomial functions, and we've discussed polynomial functions before, and their domain and range are just, both of them are r's. So the set of all possible natural numbers. So the set of all real numbers. Now for the root functions, we need to understand that under the square root function, there cannot exist a negative number. So the square root of negative 1 is undefined, the square root of negative 2 is undefined, and so on and so forth. So under the square root function only exists a domain of 0 up to infinity, and the range is also 0 up to infinity. And for the case of the reciprocal function, we have to make sure that our denominator cannot be a 0, not a negative number, but 0. The denominator should not be 0. So the domain and range of the reciprocal function, so the domain is the set of all real numbers except where x equals to 0, and the range is equal to also the set of all real numbers except for where x equals to 0. So in this section we have talked about the power function. The power function is the function with the general form of x to the power of n. N is a constant and can be equal to 0, where the power function will be equal to x to the power of 0, which is 1. The domain and range of this function are the set of all possible real numbers, and the range is equal to 1. And for the case where the power function has n equal to 1, 2, 3, and 4, and so on and so forth, we will get polynomial functions, and the domain and range of polynomial functions are the set of all real numbers. For the case where n is a fraction like 1 over a, we get power functions of the form x to the power of 1, x to the power of a half, x to the power of a third. We call these functions root functions, and the domain and range of these root functions is equal to 0 up to infinity, because under the square root function there cannot exist a negative number. For the case where n is less than 0, we get power functions of the form x to the power of negative 1, x to the power of negative 2, x to the power of negative 3, and so on, so forth. These functions are called reciprocal functions, and the domain and range of the reciprocal function will have to make sure that our denominator cannot be equal to 0. So the domain and range are both equal to the set of all real numbers except where x is equal to 0 or where the denominator is equal to 0.